What if everything you think you know about time is wrong? What if the ticking clock, the rising and setting sun, and even the aging of your body are just illusions, constructs created by the human mind to make sense of a universe that operates far beyond our understanding? Time seems like the most fundamental aspect of existence, something so ingrained in our lives that questioning it feels almost absurd. Yet, what if time isn't a real, tangible thing but a framework we've built to navigate the complexities of reality? In this video, we're about to explore 15 groundbreaking theories that challenge the very nature of time, theories that could shatter your perception of reality and leave you questioning everything you thought you knew. From the idea that time might be an illusion to the possibility that it's a byproduct of our consciousness, these theories don't just tweak our understanding of the universe, they upend it entirely. Modern science and philosophy are beginning to unravel the fabric of time itself, revealing insights that could redefine not only how we see the world but also how we shape our future. This isn't just a journey through abstract ideas, it's a deep dive into concepts that could change the way we live, think, and even exist. So, are you ready to step into a world where time is no longer what it seems? Let's start with the first theory, the idea that time might not flow at all, that it's nothing more than a mental construct, a tool created by our brains to make sense of the chaos around us. Einstein once said, "The distinction between past, present, and future is only a stubbornly persistent illusion." This idea might sound startling at first, but it challenges one of the most basic assumptions we have about reality, that time flows in a straight line from past to future. What if, instead of being a fundamental feature of the universe, time is something our minds create to organize our experiences? Think about how you perceive time in your daily life. When you're engrossed in a thrilling movie, hours can feel like minutes. Yet when you're waiting in line, even a few minutes can stretch on forever. This inconsistency in how we experience time suggests that it might not be as objective as we think. Neuroscience reveals that our brains don't process time as a continuous stream, but rather as a series of discrete moments like frames in a film. These moments are then stitched together by our consciousness to create the illusion of a flowing timeline. Psychology adds another layer to this mystery. Studies show that trauma, stress, or even extreme focus can distort our sense of time. For example, during a life-threatening event, people often report that time seems to slow down. This phenomenon, known as time dilation, suggests that our perception of time is deeply tied to our mental state. So, if time isn't an external force but a construct of our minds, what does that mean for the way we understand reality? This idea doesn't just challenge our personal experiences, it also raises profound questions about the nature of existence itself. If time is an illusion, then the past, present, and future might not be as separate as we believe. Some philosophers and physicists argue that all moments exist simultaneously, and our perception of time as a linear progression is merely a way for our brains to make sense of an otherwise incomprehensible universe. But if time is a construct, what role does it play in the physical world? This is where science takes the stage, offering theories that redefine time in ways that go far beyond human perception. And as we'll see next, physics has its own radical ideas about what time really is or isn't. What if time isn't just something we experience, but something woven into the very fabric of the universe? This brings us to our second theory, the idea that time is not separate from space but intricately connected to it as the fourth dimension. This revolutionary concept comes from Einstein's theory of relativity, which fundamentally changed how we think about the cosmos. Instead of viewing space and time as independent entities, Einstein proposed that they are part of a single, unified structure called spacetime. Imagine spacetime as a loaf of bread. Each slice of that loaf represents a moment in time, a snapshot of the universe at a particular instant. In this model, the past, present, and future are all real and coexisting, just like every slice of bread exists within the loaf. What we perceive as the flow of time is simply our movement through these slices, one after another. But here's the mind-bending part. From the perspective of spacetime, all those slices, all those moments are equally real. The now you're experiencing is just one slice among countless others. Einstein's theory also introduced the concept of relativity, which means that time isn't absolute. It can stretch, compress, or even appear to stop depending on how fast you're moving or how strong gravity is around you. For instance, if you were to travel near the speed of light, time would slow down for you compared to someone standing still. Similarly, if you were near a black hole where gravity is incredibly intense, time would pass much more slowly for you than for someone far away from its pull. This idea shatters the notion of a universal now, suggesting that what's happening right now depends entirely on your frame of reference. This theory doesn't just challenge our everyday experience of time, it redefines it. If past, present, and future all coexist within spacetime, then the idea of time as a linear progression becomes more of a human construct than a universal truth. It raises profound questions about free will, destiny, and the nature of reality itself. Are we truly moving through time, or are we simply experiencing one slice of spacetime after another, like frames in a cosmic film? But if time is a dimension, is it the only one, or could there be more? This leads us to even more complex theories that push the boundaries of our understanding. Could time be part of a higher dimensional structure, or is it something far more elusive than we've imagined? As we dive deeper into these ideas, the nature of time becomes even more mysterious and even more fascinating. If the past, present, and future all exist simultaneously, what does that mean for the flow of time, or even for our sense of self? This brings us to the block universe theory, a mind-bending concept that paints the cosmos as a static, unchanging block where every moment, every event, every decision already exists. Picture the universe as a movie reel. Every frame on that reel represents a specific moment in time, and all those frames exist at once. But instead of watching the movie from beginning to end, we're experiencing it one frame at a time, moment by moment. This is how the block universe theory reimagines reality, not as a flowing river, but as a frozen landscape where every point in time is equally real. This idea aligns closely with Einstein's theory of relativity, which we explored earlier. If spacetime is a four-dimensional structure, then every event, whether it happened, is happening, or will happen, is simply a fixed point within that structure. Your birth, your first steps, and even your last breath are all etched into the fabric of the universe like coordinates on a cosmic map. From this perspective, the future isn't something that's yet to happen, it's already there, waiting for you to experience it. But if the future is already written, does that mean our choices are an illusion? This is where the block universe theory collides with one of humanity's most deeply held beliefs, free will. If every decision you'll ever make is already set in stone, are you truly in control of your life? Philosophers and scientists have debated this question for centuries, and the block universe theory only adds fuel to the fire. Some argue that free will is compatible with this model, suggesting that our choices are still our own, even if they're predetermined within the block. Others see it as proof that free will is nothing more than a comforting myth. This theory doesn't just challenge our understanding of time, it forces us to rethink the very nature of existence. If the past, present, and future are all equally real, then the distinction between them might be more about perception than reality. It's as if the universe is a grand tapestry, and we're seeing it one thread at a time, unable to grasp the full picture. But what if time isn't even the continuous, unbroken stream we imagine it to be? What if, instead of flowing smoothly, it's made up of tiny, discrete chunks? This idea takes us to our next theory, where the concept of time becomes even more fragmented and even more fascinating. What if time isn't a continuous, flowing river, but more like a series of still frames in a film, each one distinct and separate from the next? This brings us to our fourth theory, the idea that time might not be smooth at all, but instead exists in tiny, indivisible units called Chronons. Just as light comes in packets called photons and energy is quantized in quantum mechanics, time itself might be broken down into the smallest possible increments. These chronons would represent the fundamental building blocks of time, the smallest ticks of the cosmic clock. Quantum mechanics has already shown us that the universe operates in discrete steps at the smallest scales. Energy, for example, isn't infinitely divisible, it comes in specific, quantized amounts. If time follows the same rules, it would mean that there's a limit to how finely we can slice it. Imagine trying to measure time with a ruler that only has markings at specific intervals. Anything smaller than that interval simply wouldn't exist. This concept challenges our everyday experience of time as something that flows seamlessly, suggesting instead that it might jump from one moment to the next, like flipping through the pages of a book. The implications of this theory are staggering. If time is quantized, then there's a smallest possible unit, a moment beyond which time cannot be divided. This could fundamentally change how we understand everything from the workings of the universe to the nature of reality itself. For instance, if time moves in discrete steps, what happens in the gaps between those steps? Does the universe pause, or is there some kind of transition that we're not aware of? These questions push the boundaries of both physics and philosophy, forcing us to reconsider what we think we know about the flow of existence. Quantum experiments have already hinted at the possibility of time being quantized. In the world of particles, events don't always follow the smooth, predictable patterns we see in everyday life. Instead, they occur in sudden, unpredictable bursts. This unpredictability could be a sign that time itself operates in a similar way, jumping from one state to another without passing through the intermediate stages. If this is true, then our perception of time as a continuous stream might be nothing more than an illusion, a kind of cosmic sleight of hand created by the way our brains process information. But if time is made up of these tiny, discrete units, what does that say about the nature of reality? Could it mean that the universe itself operates in a series of snapshots, with each moment existing independently of the ones before and after it? And if so, what connects these moments? Is there some underlying mechanism that stitches them together, or are we simply perceiving a connection where none truly exists? This theory doesn't just challenge our understanding of time, it forces us to rethink the very fabric of the universe. If time is quantized, then our experience of it as a smooth, flowing entity might be nothing more than a trick of the mind. And if that's the case, what else about reality might we be misinterpreting? This idea opens the door to even more radical possibilities, including the notion that time itself might not be a fundamental feature of the universe but a byproduct of something else entirely. And that's where our next theory takes us into a world where time might not even exist in the way we think it does. What if time isn't a fundamental part of the universe but something that emerges from deeper, more basic processes? This leads us to our fifth theory, the idea that time might not be a fundamental feature of reality but an emergent property, a kind of side effect of more fundamental interactions. Think of it like ripples on the surface of a pond. The ripples aren't the pond itself, they're the result of something deeper, like a stone being thrown into the water. In the same way, time might not be a basic building block of the universe, but a phenomenon that arises from the complex interplay of quantum interactions. This theory aligns with something called the holographic principle, a concept that suggests our three-dimensional reality, including time, might actually be a projection of deeper, two-dimensional processes. Imagine the universe as a hologram where every point in space and time is encoded on a boundary like the surface of a sphere. From this perspective, time isn't something that exists independently. Instead, it emerges from the way information is processed and projected. It's as if the universe is running a kind of cosmic simulation, and time is just one of the outputs. But if time is emergent, what does that mean for our understanding of reality? For one, it challenges the idea that time is a fixed, universal constant. Instead, it suggests that time could vary depending on the underlying processes that give rise to it. Just as ripples on a pond can change depending on the size of the stone or the depth of the water, time might behave differently in different parts of the universe. This could explain why time seems to flow differently near black holes or at the quantum scale, where the rules of physics as we know them start to break down. This theory also raises profound questions about the nature of existence itself. If time is emergent, then the past, present, and future might not be as distinct as we think. Instead, they could be different facets of the same underlying reality, like different patterns of ripples on the same pond. This idea blurs the line between cause and effect, suggesting that the flow of time might not be as straightforward as we've always assumed. But here's where it gets even more intriguing. If time is an emergent property, could it also be manipulated or even reversed? This leads us to the concept of time loops, where the flow of time isn't linear but cyclical, folding back on itself in ways that defy our everyday experience. And as we'll see next, this idea opens the door to some of the most fascinating and mind-bending possibilities in modern physics. What if time didn't just move forward in a straight line but looped back on itself, creating a kind of cosmic circle where the past, present, and future are all connected? This brings us to our sixth theory, closed timelike curves and the mind-bending concept of time loops. Imagine a path through spacetime that twists and turns, eventually looping back to its starting point. In this scenario, time isn't a one-way street, it's more like a Möbius strip, where the end meets the beginning, creating a continuous cycle. This idea isn't just science fiction. It's a serious possibility that arises from Einstein's equations of general relativity. In the film Interstellar, we see this concept brought to life as astronauts explore a planet orbiting a black hole, where time stretches and folds in strange ways. For every hour they spend on the surface, years pass back on Earth. While the movie takes creative liberties, it's rooted in real science. Einstein's theory allows for solutions where spacetime becomes so distorted that it curves back on itself, creating what physicists call a closed timelike curve. In theory, if you could follow such a curve, you might end up right back where you started, not just in space but in time. But what would that mean for reality? If time loops exist, could we travel back to the past and change it? This is where things get tricky and where paradoxes come into play. Take the infamous grandfather paradox, for example. If you traveled back in time and prevented your grandparents from meeting, you'd effectively erase your own existence. But if you never existed, how could you have traveled back in time to change anything in the first place? This kind of logical inconsistency suggests that time loops, while mathematically possible, might be far more complicated than they seem. Despite the paradoxes, closed timelike curves remain a fascinating area of study in physics. Some scientists argue that these loops could exist in extreme environments, like near the singularity of a black hole or in the presence of exotic matter with negative energy. Others believe that the universe might have built-in safeguards to prevent such paradoxes, ensuring that even if time loops exist, they wouldn't allow for changes to the past. This raises an intriguing question. Could time loops be part of a larger cyclical structure where events repeat endlessly in an eternal loop? This idea of cyclical time isn't new. Ancient civilizations like the Greeks and Hindus often viewed time as a repeating cycle rather than a linear progression. Modern physics, with its closed timelike curves, offers a scientific twist on this ancient idea. But if time is cyclical, does that mean history is destined to repeat itself, or could there be variations within each loop? And if so, how would we even know if we're living through the same events over and over again? As we ponder these questions, we begin to see time not as a fixed, unchanging force, but as something far more fluid and dynamic. But if time can loop back on itself, could it also branch out, creating multiple timelines or parallel realities? This leads us to our next theory, where the concept of time becomes even more complex and even more fascinating. What if the universe doesn't have a single, definitive beginning or end, but instead exists in an endless cycle of birth, death, and rebirth? This brings us to our seventh theory, cyclic time, an idea that has fascinated humanity for millennia. Unlike the linear view of time we're accustomed to, where events move in a straight line from past to future, cyclic time suggests that the universe operates in repeating loops, like a cosmic clock that resets itself over and over again. This concept isn't new. Ancient civilizations across the globe have embraced the idea of cyclical time in their myths, religions, and philosophies. In Hinduism, for example, time is divided into vast cycles called yugas, each spanning thousands of years, with the universe undergoing creation, preservation, and destruction before starting anew. The Stoics of ancient Greece also believed in a cyclical universe, where cosmic events repeated themselves in an eternal recurrence. Even the Mayans and Aztecs incorporated cyclic time into their calendars, viewing history as a series of repeating patterns rather than a linear progression. But is there any scientific basis for this idea? Surprisingly, yes. Modern physics offers its own version of cyclical time through theories like the cyclic model of the universe. According to this model, the Big Bang wasn't a one-time event but part of an ongoing cycle. In this scenario, our universe expands, contracts, and then explodes again in a never-ending loop. Some versions of this theory even suggest that each cycle leaves behind traces of the previous one, encoded in the cosmic microwave background radiation, the faint echo of the Big Bang that permeates the universe. This raises a profound question. If time is cyclical, does that mean history repeats itself? Could the rise and fall of civilizations, the emergence of life, and even the formation of galaxies be predestined to happen over and over again? Philosophers have long grappled with this idea, with some arguing that cyclical time implies a kind of cosmic determinism, where every event is fated to recur. Others see it as an opportunity for renewal, a chance for the universe, and perhaps even humanity, to learn, grow, and evolve with each cycle. But here's where things get even more intriguing. If time is cyclical, could we ever detect evidence of previous cycles? Some scientists believe it's possible. For instance, if two universes collided during a previous cycle, the energy released might leave behind detectable imprints in our current universe. These imprints could serve as clues, helping us piece together the history of the cosmos across countless cycles. This theory doesn't just challenge our understanding of time, it redefines it. If the universe is caught in an endless loop, then the past, present, and future might not be as separate as we think. Instead, they could be part of a grand, repeating pattern, like the seasons of a cosmic year. But if time is cyclical, could it also be something else entirely? What if time isn't just a repeating loop but a kind of projection, a hologram created by deeper, more fundamental processes. This idea takes us to our next theory, where time becomes even more mysterious and even more fascinating. What if time isn't a fundamental part of reality but a kind of illusion, a projection created by something far simpler? This brings us to our eighth theory, the idea that time might be a hologram, a three-dimensional illusion emerging from information encoded on a two-dimensional surface. Known as the holographic principle, this theory turns our understanding of reality on its head, suggesting that the universe we experience might not be as it seems. Imagine a holographic sticker. When you look at it, you see a three-dimensional image, but in reality, the information creating that image is stored on a flat, two-dimensional surface. The holographic principle applies a similar concept to the entire universe. According to this idea, all the information about our three-dimensional world, including time, might be encoded on a distant two-dimensional boundary. From this perspective, time isn't a fundamental feature of the cosmos but a kind of shadow, a projection created by the way information is processed and displayed. This theory has its roots in black hole physics. When matter falls into a black hole, it's thought to leave behind a kind of imprint on the event horizon, the point of no return. This imprint contains all the information about the matter that was swallowed. The holographic principle takes this idea a step further, suggesting that the entire universe operates in a similar way. Just as a holographic sticker creates the illusion of depth, the universe might create the illusion of time and space from information stored on a two-dimensional surface. But if time is a hologram, what does that mean for our experience of reality? For one, it challenges our understanding of dimensionality. We perceive the world in three spatial dimensions plus time, but the holographic principle suggests that these dimensions might not be fundamental. Instead, they could emerge from simpler, lower-dimensional processes. It's as if the universe is running a kind of cosmic simulation, and time is just one of the outputs. This theory also raises profound questions about the nature of time itself. If time is an illusion created by deeper processes, then the past, present, and future might not be as distinct as we think. Instead, they could be different facets of the same underlying reality, like different patterns of light on a holographic sticker. This idea blurs the line between cause and effect, suggesting that the flow of time might not be as straightforward as we've always assumed. But here's where it gets even more intriguing. If time is a hologram, could it also be subjective? Could different observers experience time in completely different ways, depending on how they process the underlying information? This leads us to our next theory, where time becomes not just an illusion but something deeply personal, a construct shaped by our individual perceptions and experiences. What if time isn't something that exists out there in the universe but something that's deeply personal, shaped by our individual experiences and perceptions? This brings us to our ninth theory, subjective time, the idea that time isn't an objective, universal constant but a fluid, ever-changing experience that varies from observer to observer. This concept isn't just philosophical, it's rooted in Einstein's theory of relativity, which revolutionized our understanding of time by showing that it's not the same for everyone. Take the famous twin paradox, for example. Imagine two twins, one stays on Earth while the other travels through space at near light speed. When the traveling twin returns, they'll find that less time has passed for them compared to their sibling on Earth. This isn't science fiction, it's a direct consequence of Einstein's theory, which shows that time slows down for objects in motion relative to those at rest. The faster you move, the slower time flows for you. But here's the kicker: both twins would feel like time is passing normally in their own frame of reference. It's only when they compare their experiences that the difference becomes apparent. This idea doesn't just apply to motion, it also extends to gravity. Near a massive object like a black hole where gravity is incredibly strong, time slows down dramatically. An observer far away from the black hole would see time almost stand still for someone near its event horizon. Yet, for the person close to the black hole, time would feel completely normal. These examples show that time isn't a fixed, universal backdrop, but something that bends and stretches depending on where you are and how you're moving. But if time is subjective, what does that mean for our understanding of reality? Can we ever truly agree on what now means for someone on Earth? Now might be the moment you're reading this sentence. But for an astronaut traveling at high speeds or near a massive object, now could be something entirely different. This raises profound questions about the nature of simultaneity, the idea that two events can happen at the same time. According to relativity, simultaneity is relative to what's now for one observer might be the past or future for another. This theory challenges our everyday experience of time as something shared and universal. It suggests that our perception of time is deeply tied to our individual circumstances, from our speed to our position in a gravitational field. But if time is so subjective, could it also be something we construct in our minds? This idea takes us to the next theory, where time becomes not just a physical phenomenon but a mental one, a construct shaped by the way our brains process the world around us. What if time isn't something that exists independently in the universe, but rather a creation of our own minds? This brings us to our 10th theory, the idea that time is a mental construct, a framework our brains use to organize and make sense of the world around us. Think about it, we don't directly perceive time the way we see colors or hear sounds. Instead, we experience it through the flow of events, the fading of memories, and the anticipation of what's to come. In this view, time isn't an external force but a tool our minds have developed to navigate the chaos of existence. Our brains are constantly stitching together moments, creating a sense of continuity that feels like a flowing river. But this flow isn't as seamless as it seems. Studies in psychology reveal that our perception of time is deeply tied to our mental state. For example, during a crisis or a life-threatening event, time often seems to slow down. This phenomenon, known as time dilation, occurs because our brains go into overdrive, processing information at an accelerated rate. Every second feels stretched, every detail becomes vivid. Yet, when we're bored or waiting in line, time drags on, making minutes feel like hours. These inconsistencies suggest that time, as we experience it, is less about an objective clock and more about how our minds interpret the world. Memory and anticipation play a huge role in shaping our sense of time. Our brains store past experiences as memories, creating a narrative that gives us a sense of the past. At the same time, we project ourselves into the future, imagining what might happen next. This interplay between memory and anticipation creates the illusion of a linear timeline, connecting the dots between what was and what will be. But here's the twist. If time is a mental construct, does it exist outside of our minds? Could the universe operate without time, and we're simply imposing this framework to make sense of it? This idea isn't just philosophical, it has real-world implications. For instance, people with certain neurological conditions like amnesia or Alzheimer's often lose their sense of time. Without the ability to form new memories or anticipate the future, their experience of time becomes fragmented, even non-existent. This suggests that our perception of time is deeply intertwined with how our brains function. If our brains were wired differently, would we even experience time at all? But if time is a product of our consciousness, what does that mean for the universe? Could time exist independently of human perception, or is it something that only comes into being when we observe it? This question blurs the line between the physical world and our mental experience of it, raising profound questions about the nature of reality itself. And as we ponder these questions, we're led to an even more radical idea: the concept of timelessness, a state where time, as we know it, doesn't exist at all. This takes us to our next theory, where the very notion of time dissolves into something far more mysterious and profound. What if time doesn't exist at all, not as a flowing river, not as a series of moments, but as nothing more than an illusion, a trick played on us by the way we perceive reality? This brings us to our 11th theory, timeless physics, the radical idea that time might not be a fundamental feature of the universe. Instead, it could be a kind of mirage, something our minds create to make sense of a world that operates outside the bounds of past, present, and future. One of the most compelling voices in this field is physicist Julian Barber, who proposes that time doesn't exist at the most basic level of reality. In his view, the universe isn't a series of events unfolding over time, but a collection of nows, static snapshots, like pages in a photo album. Each page represents a complete, self-contained moment, with no inherent connection to the pages before or after it. The flow of time, according to Barber, is an illusion created by the way these moments are arranged. It's as if the universe is a giant jigsaw puzzle, and our brains are piecing together the images to create the illusion of motion and change. But if time is just an illusion, how do we explain the undeniable reality of change? After all, we see the seasons shift, watch children grow, and witness stars being born and dying. Barber suggests that change isn't about time, but about the relationships between these nows. Each moment contains all the information needed to describe the universe at that instant, and the differences between moments create the appearance of change. It's like flipping through a photo album. The pictures don't move, but the progression from one image to the next gives the impression of motion. This idea challenges not just our understanding of time, but also the very foundation of physics. Most of our scientific theories, from Newton's laws to Einstein's relativity, are built on the assumption that time is a fundamental part of reality. If time is an illusion, these theories might need to be rethought from the ground up. Some physicists are already exploring this possibility, developing new frameworks that don't rely on time as a basic ingredient. But here's the real mind bender. If time doesn't exist, what does that mean for our experience of reality? Could the past, present, and future all be happening at once, with our brains simply organizing them into a linear sequence? And if so, what connects these moments? Is there some deeper structure that underlies the illusion of time, or is it truly just a trick of perception? This theory opens the door to even more fascinating possibilities, including the concept of time crystal structures that repeat not in space but in time. These exotic forms of matter could offer clues about the nature of timelessness, hinting at a universe where time isn't what we think it is. And as we'll see next, this idea takes us into a world where time becomes not just an illusion but something even more mysterious. A pattern that repeats itself endlessly, like a cosmic dance frozen in place. What if time could crystallize, not in the way water freezes into ice, but as a new state of matter that defies everything we thought we knew about the universe? This brings us to our 12th theory, time crystals, a groundbreaking discovery that has shaken the foundations of physics and challenged our understanding of time itself. Unlike ordinary crystals, which repeat their atomic patterns in space, like the geometric structure of a diamond, time crystals repeat their patterns in time. They oscillate between states without any external energy input, creating a kind of perpetual motion machine that seems to break the rules of classical physics. The concept of time crystals was first proposed by Nobel laureate Frank Wilczek in 2012. but it wasn't until recent experiments that scientists were able to bring this idea to life. Using advanced quantum systems, researchers created structures that cycle through their states in a regular, repeating pattern, like a clock ticking without being wound. These crystals don't just exist in space, they exist in time, oscillating between configurations in a way that's entirely new to science. Imagine a pendulum that swings back and forth forever, not because of an external force, but because of the inherent properties of the system itself. That's the essence of a time crystal, but how does this challenge our understanding of time? For one, it introduces the idea of time symmetry breaking. In physics, symmetry is a fundamental principle that describes how systems behave under certain transformations. For example, a snowflake looks the same when rotated by 60 degrees. It has rotational symmetry. But time symmetry suggests that the laws of physics should work the same whether time is moving forward or backward. Time crystals break this symmetry by creating a repeating pattern that only moves in one direction through time. It's as if the universe has a preferred direction, a kind of arrow of time that's built into the fabric of reality. The discovery of time crystals has far-reaching implications, not just for our understanding of time, but also for technology. One of the most exciting applications is in quantum computing, because time crystals are incredibly stable and resistant to external disturbances. They could be used to create error-resistant quantum systems, revolutionizing how we process information. Imagine a quantum computer that doesn't lose coherence over time, maintaining its delicate quantum states indefinitely. This could pave the way for breakthroughs in fields like cryptography, materials science, and even artificial intelligence. But here's the real kicker. Time crystals might also shed light on the nature of time itself. If matter can exist in a state that repeats in time, does that mean time is more than just a backdrop for events? Could it be an active participant in the universe, shaping the way matter behaves? This idea takes us into uncharted territory, where time isn't just a dimension but a dynamic force that interacts with the physical world. As we marvel at the possibilities of time crystals, another question arises. If time can crystallize, could it also be a form of energy? This thought takes us to the edge of our understanding, where the boundaries between time, matter, and energy blur into something entirely new. And as we'll see next, this idea opens the door to even more radical theories about the nature of reality. What if time isn't just a dimension or an illusion, but something far more dynamic, a form of energy itself? This brings us to our 13th theory, the idea that time could be a type of energy, much like space is treated in Einstein's theory of general relativity. In this view, time isn't just a passive backdrop for events. It's an active participant capable of storing, transferring, and even releasing energy. Imagine time as a kind of cosmic battery, holding the potential to power the universe in ways we're only beginning to understand. To grasp this concept, let's revisit Einstein's groundbreaking equation, E equals mc squared. This equation shows that energy and matter are interchangeable, two sides of the same coin. But what if time is part of that equation too? Some physicists suggest that time might have its own energy-like properties, interacting with matter and space in ways that could fundamentally alter our understanding of the universe. Think of it like this: if space can warp and bend under the influence of gravity, perhaps time can do the same, storing energy in its curvature and releasing it in ways we're only starting to imagine. This theory opens up fascinating possibilities. For instance, if time is a form of energy, could we harness it? Imagine a future where we tap into the energy of time itself, using it to power technologies we can't yet conceive. It might sound like science fiction, but the history of physics is full of ideas that once seemed impossible until they weren't. From the discovery of electricity to the harnessing of nuclear energy, humanity has repeatedly found ways to unlock the secrets of the universe. Could time be the next frontier? But here's where things get even more intriguing. If time is energy, it could also provide a missing link in our understanding of the cosmos. One of the biggest challenges in physics is unifying quantum mechanics, which governs the tiny world of particles, with general relativity, which describes the large-scale structure of the universe. Time as energy might offer a bridge between these two theories, providing a framework that connects the microscopic and the macroscopic in ways we've never seen before. This could lead to breakthroughs in everything from cosmology to quantum computing, reshaping our understanding of reality itself. Of course, this theory raises questions too. If time is energy, how does it interact with the other forces of nature? Could it decay like other forms of energy, or is it somehow conserved? And what would it mean for the flow of time if we could manipulate its energy? These are questions that physicists are only beginning to explore, but the possibilities are as exciting as they are profound. As we consider the idea of time as energy, another thought emerges. If time can store and release energy, could it also carry information? This leads us to the next theory, where time becomes not just a dimension or a force, but a medium for transmitting knowledge, a kind of cosmic library that holds the secrets of the universe itself. What if time isn't a physical force or a dimension, but something far more abstract, a flow of information? This brings us to our 14th theory, the idea that time might not be a tangible feature of the universe but a process of information exchange and organization. Think of it like the code running on a computer. The computer doesn't feel time, it processes data one step at a time, creating the illusion of a sequence. In the same way, time could be the result of how information is processed and arranged in the universe, giving us the sense of a flowing timeline. This theory ties closely to one of the most perplexing mysteries in physics, the information paradox of black holes. When matter falls into a black hole, it's thought to be lost forever, taking all its information with it. But this contradicts a fundamental principle of quantum mechanics: information can't be destroyed. The holographic principle, which we explored earlier, offers a potential solution. It suggests that all the information swallowed by a black hole isn't lost but encoded on its event horizon, like data written on a two-dimensional surface. From this perspective, time could be the way this information is processed and projected, creating the illusion of a flowing, three-dimensional reality. To better understand this, let's draw a parallel from computer science. Imagine your computer processing a video file. The video isn't stored as a continuous stream. It's broken into individual frames, which are then played back in sequence to create the illusion of motion. Similarly, the universe might operate on a fundamental level where information is processed in discrete steps, and the flow of time is how we experience that sequence. It's as if reality is a cosmic computer, and time is the program it's running. But if time is just a flow of information, what does that mean for the nature of reality? Could the universe itself be a kind of computation, with time as the process that updates its state? This idea, known as the computational universe hypothesis, suggests that everything from the motion of planets to the firing of neurons in your brain could be part of a vast cosmic computation. In this view, time isn't something that exists independently. It's the result of how information is being processed at the most fundamental level. This theory also raises a fascinating question. If time is information, could we manipulate it? Just as we can alter the speed of a video by changing the frame rate, could we, in theory, change the flow of time by altering how information is processed? While this might sound like science fiction, it's not entirely out of the realm of possibility. Quantum computers, which operate on the principles of information processing, are already hinting at how we might harness the power of information to perform tasks that classical computers can't. Could future technologies allow us to control the flow of time itself? As we explore this idea, another thought emerges. If time is a flow of information, could the universe itself be a simulation? This is where our journey takes us next, into a theory that pushes the boundaries of science and philosophy, the idea that reality might be a kind of cosmic program with time as the code that makes it run. Could we be living in a universe that's not just governed by physical laws, but by the rules of computation? And if so, what does that say about the nature of existence itself? What if everything you've ever experienced, every sunrise, every heartbeat, every moment of joy or sorrow wasn't real? What if the universe itself, including time, was nothing more than an elaborate simulation, like a video game programmed by some advanced civilization? This brings us to our 15th and final theory, the simulation hypothesis, a concept that has sparked intense debate among scientists, philosophers, and even tech billionaires. It's a theory that doesn't just challenge our understanding of time, it questions the very nature of reality itself. The idea isn't new. Philosophers have pondered the nature of reality for centuries, from Plato's allegory of the cave to Descartes' famous declaration, "I think, therefore I am." But in the modern era, the simulation hypothesis has gained traction thanks to thinkers like Nick Bostrom, who proposed a thought experiment suggesting that it's more likely than not that we're living in a simulation. His argument goes like this: if a civilization ever develops the technology to create simulations indistinguishable from reality, and if they choose to run countless such simulations, the odds are that we're in one of those simulations rather than the base reality. To grasp this idea, think about how video games work. In a game like The Sims or Grand Theft Auto, time moves forward as the program processes data and updates the virtual world. The characters in the game experience time as a linear progression, but to the player, it's just a series of computations. Now imagine scaling that up to the level of an entire universe. If we're in a simulation, time might simply be a product of the program's processing speed, a way for the simulation to create a sense of order and continuity. But if time is a simulation who's running the program, are we the creations of some hyper-advanced civilization, or could we ourselves be the architects of this virtual reality? Some theorists suggest that future humans might create simulations of their ancestors to study history or explore alternate timelines. Others propose that we might be living in a simulation created by an entirely alien species, one with motives we can't even begin to comprehend. This theory raises profound questions about free will, consciousness, and the nature of existence. If we're living in a simulation, are our choices truly our own, or are they predetermined by the code running the program? Could glitches in the simulation explain phenomena like déjà vu or strange coincidences? And if we ever discovered proof that we're in a simulation, how would that change the way we live our lives? As we reflect on these 15 theories, one thing becomes clear: time is far more mysterious than we ever imagined. Whether it's an illusion, a dimension, or a simulation, our understanding of time shapes how we see ourselves and the universe around us. These theories don't just challenge our perceptions, they invite us to rethink what it means to exist, to make choices, and to experience the fleeting moments that make up our lives. So, what's the truth about time? Is it a construct, a force, or something entirely beyond our comprehension? The answer might lie in the theories we've explored, or it might be waiting in the uncharted territories of science and philosophy. Whatever the case, one thing is certain: the journey to understand time is far from over. And as we continue to explore, question, and wonder, we might just uncover insights that change not only how we see the universe, but how we see ourselves. Over the course of this journey, we've explored 15 groundbreaking theories that challenge everything we thought we knew about time. From the idea that time might be a mental construct to the possibility that it's an emergent property of deeper processes, each theory offers a unique lens through which to view the cosmos. We've grappled with the notion that time could be quantized, existing in tiny, discrete chunks, and even considered the radical idea that it might not exist at all, that our perception of its flow is nothing more than an illusion. We've ventured into the realm of spacetime where past, present, and future coexist, and explored the mind-bending concept of time loops and cyclical universes. We've imagined time as a hologram, a form of energy, and even a flow of information, each theory pushing the boundaries of our understanding further than ever before. And finally, we've dared to ask the ultimate question: could time itself be part of a simulation, a construct programmed by some advanced intelligence? Each of these theories doesn't just tweak our understanding of time, it upends it. They force us to confront the possibility that time, something so fundamental to our existence, might not be what we've always assumed. It's not just a ticking clock or a flowing river. It's a complex, multifaceted phenomenon that intertwines with space, consciousness, and even the fabric of reality itself. These ideas don't just belong to the realm of abstract philosophy or theoretical physics. They have the potential to revolutionize how we see ourselves and the universe. They challenge us to rethink the nature of free will, the meaning of existence, and the very structure of reality. What if time isn't a fixed, unchanging force, but something fluid, dynamic, and deeply personal? What if our perception of it is just one small piece of a much larger puzzle? These questions don't just belong to scientists and philosophers. They're questions we all grapple with in our daily lives. Think about how you experience time, the way it flies when you're having fun, drags when you're bored, or even seems to stop in moments of crisis. These everyday experiences hint at a deeper truth that time, as we know it, might be far more subjective and malleable than we ever imagined. As we reflect on these theories, one thing becomes clear: our understanding of time is still in its infancy. Each new discovery, each new theory, peels back another layer of the mystery, revealing insights that could reshape not only science and philosophy, but also how we live our lives. Imagine a future where we harness the energy of time, navigate time loops, or even manipulate the flow of time itself. These possibilities might sound like science fiction today, but so did the idea of quantum computers or black holes just a few decades ago. So, what is time, really? Is it a dimension, an illusion, or something we can't even begin to comprehend? The answer might lie in the theories we've explored, or it might be waiting in the uncharted territories of science and philosophy. As the physicist Carlo Rovelli once said, time is not what it seems. It does not flow in one direction, and the future exists already. This idea, both unsettling and exhilarating, invites us to keep questioning, keep exploring, and keep wondering. As we wrap up this journey, we'd love to hear your thoughts. Which of these theories resonates with you the most? Do you think time is a construct, a force, or something else entirely? Share your ideas in the comments below, and don't forget to subscribe for more mind-bending explorations into the mysteries of the universe. The nature of time might remain elusive for now, but one thing is certain: the quest to understand it is far from over. And who knows, the next breakthrough might just come from you.